Hi, I'm Rob Morton. I want to tell you about a lab that I wrote and implemented to investigate the different types of color and how we can get color through pigments versus how we can get color through interference and structural color. Um, so I implemented this lesson in a high school honors physics course and an honors STEM physics course. Um, So previously, students had already learned about wave interactions, so interference, reflection, refraction, diffraction, um, and they had um, just gone over the electromagnetic spectrum and how visible light fits on that spectrum is a small portion of it. So they were somewhat familiar with the terms frequency, wavelength, how that affects color. Um, So we started with students were given Mr. Paints. So they had different paints that were numbered, and they went around to the different stations and painted that color in that square. So I gave them a template. That one is my key. So I gave them a template, and it's a bunch of boxes. Each box is labeled with a single number. They went around and matched the number with that color paint. Um, As a side note, on mine, you're going to see two separate swaths. I was testing whether a medium gloss was needed or not. I did find that you don't need a medium gloss. I think you actually get better colors without using the medium and only using the paint. However, if you need to stretch your budget a little, the medium, the paint medium works pretty well and will let that paint last longer. Um, okay, so each student, they're working in groups. They went around to the different stations, painted, and they started making observations. So as soon as you paint, you start seeing some of the differences. Um, they used 4 different acrylics, so red, green, gold, blue, and then the rest were interference paints. So they could immediately tell the difference that some of these paints looked normal, some did not. They also had different sets of colored paper, so green, orange, red, blue, yellow, the white, and then a black piece that they had in their groups um, to go through as well for each color. So they started making some initial observations. We then stopped, broke the lesson, and continued it the next day to wait for the paint to dry. So once the paint was dry, they could see a lot more. So I don't know how much you'll be able to see on the computer, but at different angles, you get different colors. When you look at it straight on, it looks pretty clear white. Um, but as you change the angle, the light is interacting with the paint differently, the interference paints, and you get different colors. So the idea of the different colored sheets of paper where the background will absorb certain wavelengths, certain frequencies, um, and that will affect how they reflect light, how the interference wavelengths or the frequencies that are reflected back interact with the ones that pass through and then reflected off of the background sheet of paper. So the best colors were on the black paper because that background will absorb all of the other frequencies. I did find that, which I didn't know this going in, but they make interference paints that have multiple colors. So for example, this one is green orange. So at certain angles it looks green, at a different angle it looks orange. That was interesting. And the kids found that really interesting. So all that is just combining, and so at the different angles, the different size chips are refracting. Um, let's see. So once they were back and analyzing, I had them investigating the difference, trying to come up with an explanation from what they know about color, what they know about waves, interference, reflection, refraction, diffraction, and try to come up with some kind of explanation for why some of these paints look exactly the same no matter what angle, and some look completely different at different angles, and how some look exactly the same on different colored sheets of paper. Right, the red and the red look pretty much exactly the same, whereas some colors do not look the same at all. The interference paints on different backgrounds can look dramatically different. So students worked on that, and then we had a group discussion talking about how they actually work, how interference paints work. We used it as kind of an introduction into nanotech, like, hey, someone actually did this on purpose. This wasn't an accident. That there are jobs that investigate how these little tiny particles within the paint can do all kinds of different things. It was really good because I had several kids that are artists. They enjoy that aspect. And seeing them make a tie-in from their art to science was really good. But it also allowed me to kind of branch out and talk a little bit about some of the other areas of nanotech, all the different things that can be done with it. Yeah, so that was good. Some recommendations: if you're looking to shorten it, you do not need to use all 12 colors of paint. I would recommend whatever interference colors you use, you try to find an acrylic pigment-based version of that color. The ones that I think work the best are interference red, interference gold, interference violet, and interference blue. So those four work the best. The green orange and the green blue work really well if you're interested in doing the double colors. And then in terms of colored paper, black and white definitely. And then I would recommend including at least like a red and a blue and maybe a yellow to work with gold. And again, the medium gloss, I think diluted some of the colors. You would need more coats to get the same effect. However, it stretches the paint further. So if cost is a thing, a concern, you don't have the budget for it, or you have a lot of students and you need to get through a lot of them, then you can mix the paints with a medium gloss medium. But I will probably not be doing that. I think I prefer the colors from just the straight paint. And it doesn't take much to do, strips like this. I used maybe 4 or 5 drops, just making the keys. So it'll go a long way. Thank you.